Alrighty, guys, we are going to talk today about more similar stuff. So specifically, similar triangles, which are maybe a little bit easier, 167, 68, than similar polygons, only because like a polygon could have like lots and lots of sides. As we saw last time, there was like that 5-sided figure, a pentagon, or a 4-sided figure. Similar triangles are a little easier because I'm only going to do with 3 sides. So that's nice. The one kind of trickier thing about it, though, is we want to talk a little bit about proofs. If you remember, we did those flowchart proofs before to prove that triangles were congruent. We're not going to do that here. I never do that here, but we do want to explain how I would know that triangles are similar using some of those shortcuts like we talked about before. So actually, if we turn to page 67, 68, not all of the shortcuts that we talked about before will work. And in fact, some of them don't. And then some of them that didn't work for congruence do work for similarity, most specifically angle, angle. So these are the 3 ways that we can prove that triangles are similar to each other. And we don't need to, again, go through the whole long proof process. We can just say, what reason we're using. So for this one, I can use angle-angle similarity to prove that 2 triangles are similar to each other just by looking at how the picture is marked. And if 2 angles of one triangle are congruent to 2 angles of another, then at the very, very least, they will be similar to each other. Okay. So a quick little example of that. For number 1 here, are the 2 triangles similar? If so, state how and write a similarity statement. So we have the triangle XZY, and the other triangle, which is a little bit hidden, is a smaller triangle at the top, XWV. And those 2 triangles would be similar to each other because they both have this angle of 82 and they both share angle X. Like angle X is in the blue triangle and it's in the green triangle, and they're right on top, so I know that they're the same amount. So yes, the triangles are similar by angle, angle, similarity. And so my similarity statement would be that triangle XVW, so XVW, is similar to XYZ. And again, I just have to travel in the same order so that all the corresponding sides and angles match up. So another example over here, are the 2 triangles similar? If so, state how. And again, like spoiler alert, it's under here, but these 2 triangles I know are similar to each other because I noticed that we have these parallel lines, which when I have parallel lines, I can then pick a transversal, or I should pick a transversal, and then I can start to get some congruent angles, which is something I need if I want to use angle, angle. So this angle right here is alternate interior with this angle here. And now I could pick a different transversal and do a similar thing, but I also have vertical angles that are always equal no matter what. And so right now I have angle, angle. I got angles, angles, congruent. So 2 triangles are similar, yes, by angle, angle, similarity. And so we could call it triangle JHK. Oh, geez. Triangle JHK would be similar to, so I went 1 to 2 to none. So I got to do the same thing here. 1 to 2 to none. Another way that we can prove that triangles are similar to one another is by using side angle side, which we talked about before. Now, the only sneaky thing about this one, and I like using it less than angle, angle, like angle, angle is super easy. I only need 2 things, and then I know that the triangles are similar. Psh, easy. Side angle side, I need to have 3 things. And not only that, but I have to keep everything straight. So like the angles are congruent, but then the sides are proportional. And remember, proportional means like 2 ratios or 2 fractions equal. So like in this little picture here, I can see that the 2 angles are equal, but then I would have to write a proportion where I'd be doing like the square divided by the square has to be the same as the circle divided by the circle, and make sure that those all equal out to each other. If they don't, then they might not be similar. Okay, so if we try some of those out, are the 2 triangles similar? If so, state how, write the similarity statement. So I can see a side angle side thing going on, and I can see that the angles are congruent, so that's a good start. But I need to know, are the sides proportional? So the smaller side, and again, like we were doing with the polygons, you can choose how to write your fraction. You just need to be consistent. So I'm going to do the smaller triangle on top and then the bigger triangle on bottom. And so when I'm looking at the smaller triangle, of the 2 sides that I know, the smaller side is 4, which should match up with the smaller side that I know on the bigger triangle, which is 6. That needs to be the same fraction as small over big for the other sides, so 6 over 9. And like it's not super obvious right now, you could reduce both sides and see, or as always, I can cross multiply and see. Now there's nothing to solve for here, so I'm really just cross multiplying to see if they're the same. So 6 times 6 is 36. Is that the same as 4 times 9? And it sure is. So now that I know the sides are proportional, they are similar by side angle side similarity. So triangle MNL is similar to MNL PRQ. Okay, another one here. Are the 2 triangles similar? If so, state how and write a similarity statement. Again, these triangles are a little bit hidden. So we have the smaller triangle here, and then the bigger triangle there. And I do notice a side angle side thing going on because like this side is fully labeled and this side is fully labeled, and they are sharing angle L. And since they're sharing it, it is congruent on both. So the angle part is all figured. I just need to see if my sides are proportional. So maybe I'm going to do big over small this time. Just change it up. Why not? So if I go with big over small, on the big triangle, the green one, this full side length is 9, because this part is 3 and that part is 6. That matches up on the small triangle to just the 6. And I need to see, is that going to be the same ratio as this side over here, where from the big triangle, that whole side is 15, over the one it matches up with on the small blue triangle, which is just 10. Now again, we could cross multiply like the last one, or another way to do it is to reduce. So if I reduce, I can divide each of these by 3. So I get 3 over 2. And then on the other side, I can divide both those by 5. And I get 3 over 2. So I just wanted you to see that way too, because we don't have to reduce by the same amount both sides. Just when I reduce, do they reduce to the same thing? And they sure do. So yes, the triangles are similar by side angle side similarity. And so we could call it triangle ELJ. The big one is similar to triangle KLM. So everything matches up. Now, last but not least, the other way that I can prove 2 triangles are similar is by side, side, side. Now, the other ones that we learned before, angle, angle, side, that would work, but I don't even need to check the side. I just need angle, angle, or angle, side, angle. Again, that's kind of just angle, angle. So like we don't need those other ones that we talked about before. Angle side side never works, not even for similarity. So side to side will work, although this is my least favorite because, again, with similarity and sides, they're not just equal, they have to be proportional. And like side to side, I gotta check all three sides match up, like all three fractions reduced to the same amount. So like we're checking to see, is square over square the same as circle over circle, which is that the same as x over x? I don't know. We need numbers. Let's try some. So, are the two triangles similar? If so, state how. Let's just go small to big, since that's the order that they're in. So small on top, big on bottom. And then when I write the fraction, I'm going to pick a small or a side from the small triangle and match it up to its corresponding side on the big triangle. So I always like to go smallest to biggest as well, just to keep everything straight in my brain. So the smallest side on the small triangle is 7, which would have to match up to the smallest side on the big triangle, which is 21. Now this is a question, is that going to be the same ratio as medium to medium? So 12 over 30, which is that going to be the same as the last one? And I have to check all three to do side, side, side. So 15 over 45. Now the 7 over 21 reduces pretty obviously to me because 7 goes into 21 evenly. So 1/3. Same with the 15 over 45. I know 15 goes into 45 evenly 3 times, so 1/3. The real question though is here. And I don't think that that's 1/3, but I don't know, like, okay, 2 will at least go into both. No, 6 will go into both. 2 times on top and 5 times on bottom. Oh my God, that's 2 over 5. That's not right. Yeah, I mean, I reduced everything, just not similar. I felt weird because I thought they were all going to be, but they don't have to be. So no, not similar. So we're not going to write a similarity statement. And then last one to try here. So again, the two triangles we want to be looking at are the small one here and then the large one outside. And I can see that they're wanting me to try side, side, side because all the sides are labeled. So this time we'll go big over small just to change it up for funsies. But then I'm going to go in order from smallest to biggest side. So on the big triangle, the smallest side that I have is 88. That matches up, so that's this one here, with this side on the blue triangle, which isn't marked, but I do know that this part is 56. So I can subtract the 2 to figure out how big that one is. So that's 32. Then the question is that going to be the same as when I go next biggest? So next biggest on the big is 121. Is that going to be the same as the corresponding side to it, which will be the 44? And then is that going to be the same as the biggest ratio, which is 143 over this little blue, which I don't know, but if I do 143 minus 91, that's going to be 52. And so if I reduce each of those or divide each of those, let's see, 88 divided by 32. And we can do decimal land. I mean, kind of gross, but that's going to be 2.7. Is that going to be the same as 121 divided by 44? So far, so good. It's that last one, 143. If I divide it by 52, 2.5. Oh, yeah. So all the ratios are the same, which means, yes, the triangles are similar by side, side, side. And so we can call it triangle DLE is similar to triangle KLM. All right, here you go.